Solve 1 over 3x squared plus 2/3 equals 1 over x. Again, we're going to start by listing the restrictions on x. If we look at the denominators that have variables in them, one of them is 3x squared, so we know that 3x squared is not allowed to be 0. But the only way that 3x squared could be 0 was if x was 0. So we know x is not allowed to be 0. The other denominator that has a variable in it is x, and so we know also that x can't be 0, but that's the same restriction that we already had. So this is our only restriction. X cannot be 0. So on that note, let's go and solve the problem. I'm going to rewrite it over here. 1 over 3x squared plus 2/3 equals 1 over x. We know that we have to multiply by the LCD to get rid of any denominators here. The denominators contain factors of 3, and so we know the LCD has to have a 3 in it. There are also x's in the denominators. One of the fractions just has a single x, and the other one has an x squared. Remember that the LCD has to have the highest power of each factor, so this has to be x squared, because x squared is a higher power of x than just x alone. So our LCD is going to be 3x squared, so we're going to multiply both sides of this equation by 3x squared to get rid of the denominators. On the left, we're going to have to distribute. Now, in the first term, we've got a 3x squared out front and 1 in the bottom. They're going to cancel, leaving us with just the 1. So we've got 1 here, plus, in the second term, we've got a 3 in the denominator that's going to cancel with the 3 out front. And then that leaves us with this x squared times 2, which gives us 2x squared. So on the left, we have 1 plus 2x squared. Then on the right, when we multiply, this x in the denominator is going to cancel with one of the x's in the x squared. So if we cancel that x with one of those, then we're left with just the x. And so a single x times 3 gives us 3x. So we've got 1 plus 2x squared equals 3x, and we need to solve this. Notice the x squared term. This is a polynomial equation. When we want to solve polynomial equations, we need to get all the terms on the same side so that the other side is just 0, and then factor and use the 0 factor property. So let's subtract 3x on both sides to get all the terms on the left. That gives us 1 minus 3x plus 2x squared equals 0. And because we want to factor this, it's going to be easier to write it in standard form. So this is going to be 2x squared minus 3x plus 1 equals 0. We need to factor this trinomial, and because there is a leading coefficient, we're going to use the AC method. In this case, AC is 2 times 1, which gives us 2, and B is negative 3. So we need two numbers that have a product of 2 and a sum of negative 3. Those numbers are going to be negative 2 and negative 1. And we're going to use those numbers to split the middle term. So we're going to keep the 2x squared, and then the negative 3x is going to become negative 2x minus 1x, and then plus that 1. All this equals 0. And we can finish off by grouping. If we look at the first group, both of those terms have a 2x, so we're going to pull out 2x, and that leaves us with x minus 1. In the second group, the GCF is 1, but we need to pull out a negative 1 because the goal is to have a positive x as the leftovers, so we need to pull out the negative as well. If we pull out a negative 1, that leaves us with x, and then minus 1, because 1 divided by negative 1 is negative 1. And all of this still equals 0. Now we've got the same thing inside the parentheses, so that's going to be the GCF among the groups, x minus 1. And then the leftovers are 2x minus 1. So this becomes x minus 1 times 2x minus 1 equals 0. And now we use the zero factor property to set each of these factors equal to 0. So x minus 1 equals 0, or 2x minus 1 equals 0. And we can solve. We add 1 to both sides here to get x equals 1. In the other one, we also add 1 to both sides. That gives us 2x equals 1. And if we divide by 2, that gives us x equals 1/2. So there are two potential solutions, x equals 1 or x equals 1/2. Now we have to make sure that neither of these are restricted, but if we look all the way back up to our restriction, the only restriction was that x couldn't be 0. So both of these solutions are allowed, and so we keep both of them and we say that x equals 1 or x equals 1/2, and that's our final answer.